Hi, welcome back to Solid punya topic. Okay, so previously kita dah tengok the explanation on the process of freezing, melting, sublimation and deposition. So today, in this video, kita akan cover on the type of solid, ada dua, and then kita akan tengok what is the difference between those two, and then kita akan tengok a few example for the crystalline solid sahaja. Okay, so there are two types of solid class. So two types of solid, the first one is what we call as the crystalline solid. So dia kalau crystalline solid ni, it has the crystalline form, okay, nampak macam crystal macam tu, macam dalam gambar ni. And then satu lagi adalah we call it as amorphous solid. So kalau amorphous solid pula, dia tak macam crystal lah, okay, it is a solid but not in a crystalline form. So these two ada a few differences dia. So kalau kita tengok dulu the characteristic of crystalline solid. So kalau untuk crystalline solid, the atoms, ions or molecule, they are ordered in a well-defined arrangement. So crystalline punya form ni is said to be a well-defined arrangement. Okay, so it form when a saturated liquid is cooled slowly. So usually bila dia daripada liquid, okay, kita biar dia cool slowly dekat room temperature dulu, okay, and then baru kita pergi to a colder temperature lah, and then dia akan form a very nice crystal texture. Okay, kalau kita cepat-cepat sejukkan dia, the crystal actually dia jadi makin macam, instead of dia form a very large pretty punya crystal like, okay, the crystal dia akan jadi like slightly smaller actually, tapi lagi cepat kita sejukkan dia, nanti dah tak nampak dah crystal punya structure tu. So adakah dia masih lagi consider crystalline solid? Okay, tak apa, itu kita akan tengok kemudian. Okay, so form when a saturated liquid is cooled slowly. So its atom, molecules or ion, they occupy a specific position, so it has a well-defined melting point then. Okay, so for example kita ada ice, sugar ataupun salt. Okay, kalau amorphous solid pula, what is it? So the solid whose particle have no orderly structure. Okay, so they are not well arranged. And then it is formed when a saturated liquid is cooled rapidly. So this is the difference. Okay, the way kita cool down kan the saturated liquid. Crystalline solid, kita cool it down slowly, so that kita boleh dapat form the crystal structure. Tapi kalau amorphous solid, kita cool down rapidly, dengan cepatnya. So kalau dengan cepatnya kita sejukkan saturated liquid tu, so dia tak form dah the crystalline the crystal structure. Okay, macam ice cream lah. Ice cream kalau kita pergi sejukkan terus dalam freezer, kita tak dapat pun crystal tu. Tapi if something yang kita slow down kan dia punya cooling process tu, it will eventually form a crystal like, okay, crystal like solid. So kalau amorphous solid, dia tak ada a definite melting point in comparison to a crystalline solid. Okay, so for example kita ada glass, plastic material or charcoal. Okay, so crystalline solid, this is some of the example. Yang sini kita ada silicon oxide ataupun quartz. Okay, as you can see, it has a very definite shape. Okay, and then it is well arranged juga. Tapi kalau kita tengok amorphous, silicon oxide juga, tapi dia amorphous punya, okay, which is a glass. Okay, so yang ni tadi quartz, yang ni pula adalah glass. Dia punya arrangement is very random. Okay, in comparison to quartz kat sini tadi. Okay. So type of crystalline solid. So kita just nak tengok crystalline solid saja. So crystalline solid, they are divided into four. Okay, the first one adalah metallic solid, second one adalah ionic solid, the third one adalah molecular covalent solid, and the last one kita akan tengok adalah the giant covalent solid. Okay, so untuk yang the first one, metallic solid dahulu. So metallic solid, they are closely packed structure. Okay, it composed of atoms of the same metal linked together by a metallic bond. So for example, any metallic elements actually dia boleh form metallic solid ni. Okay, kita ada sodium ataupun kita ada gold kat sini. So they are considered as a metallic solid. Okay, and then kalau ionic solid pula, so ionic solid, it consists of ion. So of course kita ada cation dengan anion, which is held together by the ionic bond ataupun electrovalent bond. Okay, so for example kita ada sodium ion with chloride ion, so we can form an HCl. Okay, so an HCl ni garam lah sebenarnya. Okay, our table salt. So this one is said to be an ionic solid. Okay. Okay, and then kita tengok pula molecular covalent solid. Molecular covalent solid pula, it consists of molecules that held together by a covalent bond. Covalent bond ni usually van der Waals forces ataupun ada hydrogen bond, depends. Okay, so for example kita ada oxygen ke ataupun water, iodine or even dry ice. Itu semua adalah covalent bond. Okay, for example kalau kita ada water kat sini, so we do have a covalent bond, hydrogen bond between these two molecule, between these two water molecule. Kita ada hydrogen bond kat sini, which is shown to you by yang dash line ni. Okay, tapi antara O dengan H ni pula, okay, antara O dengan H ni, that is actually a covalent bond. Okay, and then kita tengok kepada giant. Oh, belum lagi, ini nak tunjuk example kot rasanya. Oh tak, dia ulang balik sekejap. Miss terletak double slide yang ni. Oh bukan. Okay, just nak tunjuk contoh saya kat sini. Sorry, Miss lupa saya ni. So this is the covalent structure kalau untuk kita punya, this is actually water molecule ni. Okay, this is H2O tapi dalam bentuk solid. Okay, so dia very crystalline. I mean like looks like a crystal, right? Snowflakes lah. This is actually snowflakes. Kalau kita zoom into the snowflake, kamu akan dapat nampak this particular structure. Okay, and then yang ni pula adalah carbon dioxide crystal. Okay. Okay, and last sekali kita ada giant covalent solid, tapi giant covalent solid ni a little panjang kita nak describe dia. Okay, so giant covalent solid is a very large molecule. Kalau beza dia, I mean like dia ada covalent bond, yang tadi pun ada covalent bond juga, tapi yang ni a very large molecule, sebab dia dipanggil giant. Okay, it composed of atoms linked together by a covalent bond juga. So for example kita ada diamond ke ataupun graphite or even silicon oxide. Okay, so for example kalau kita ambil diamond, okay, so ini adalah bentuk diamond sebenarnya. So kita punya carbon atom, and then carbon atom are bonded together with a covalent bond. Okay, so a giant covalent structure is formed then, and the atoms are held together by a strong covalent bond. So each carbon atom is bonded covalently to 4 other carbon atom in a tetrahedral arrangement. So as you can see, let's say kita ambil carbon kat sini, so dia membentuk tetrahedral ni. Okay, dia membentuk tetrahedral, and then yang satu lagi carbon itu nanti dia pun, yang ni pun membentuk tetrahedral juga. So dia boleh form a very large structure then. Okay, so it becomes the hardest material. So since the hardest material class, so it has a very high melting point. Untuk kita punya diamond, the melting point is up to 3550 degrees Celsius. So it does not sublime because a 3D network of strong carbon-carbon single bond. Okay, so tapi dia tak boleh nak conduct electricity. Ini, okay, kita punya diamond ni tak boleh nak conduct electricity. So it is abrasive, high refractive index, and it has a very high density. In comparison, kalau kita ada another giant covalent structure juga, kita tengok graphite. Okay, so kalau graphite, it has a layered structure. Okay, dia layered structure. So each layer ni dia bonded. Okay, kita tengok ni. Within each layer, every carbon atom is bonded covalently to 3 other carbon atoms. Lepas ni kita tengok structure dia macam mana. And then between layer tu pula, it is connected by weak van der Waals forces. Okay, so one of the electrons in the carbon atom dia boleh move freely. So disebabkan this particular carbon atom, dia somehow boleh conduct electricity and also heat. Okay, so this is the structure actually. Tadi dia mention about carbon, satu carbon atom tu bonded to another 3 carbon kan. So as you can see, one kat sini, so each carbon atom tu dia bonded kepada another 3 carbon atom. Okay, so ni one layer. Okay, this one adalah one layer. This is just a small part of graphite lah. Sebab kalau ikutkan layer dia besar, banyak lagi. Yang sini ada lagi connect dengan benda-benda carbon-carbon yang lain. Okay, and then each layer ni pula are connected by the van der Waals forces. Okay, so kalau ciri-ciri graphite ni pula, so it is actually soft. Okay, in comparison to diamond, diamond is a very hard one. Okay, tapi still disebabkan dia a very large molecule. Okay, that's why dia punya melting point pun still high lah despite the soft. Okay, but then it has a lower density, and since ada carbon yang boleh bergerak tu tadi, it is actually a good electrical conductor. Okay, and then in terms of application, usually kita guna dalam pensel, okay, ataupun sebagai electrodes in batteries, ataupun kita guna dekat industrial electrolysis process. Okay, so in conclusion, untuk the 4 types of kita punya crystalline solid tu tadi, in terms of force yang hold all the units together. Kalau dalam metallic solid tadi, it is held by metallic bond. Kalau ionic bond lah, okay, ataupun electrostatic attraction between cation dengan anion. Kalau molecular covalent pula, it is connected by the van der Waals ataupun hydrogen bond. Okay, kalau giant covalent bond lah. Okay, in terms of general properties, kalau metallic, it is soft to hard, depends dengan type of metal tu, and then so melting point dia pun varies juga from low to a high boiling point, but then it is a very good conductor of heat and electricity since dia dipenuhi dengan sea of electrons kan, metallic bond. Okay, so for example, semua metal. Okay, kalau ionic pula, general properties dia, it is hard, brittle, but then it has a high melting point, but then it is a poor conductor of heat and electricity sebenarnya. So for example, macam garam, okay, ataupun calcium carbonate kat sini. Okay, and then kalau van der Waals forces pula, so van der Waals forces, molecular covalent solid. So ini pula, it has a soft structure, so boiling point ataupun melting point dia pun rendah juga, and then it is a poor conductor of heat and electricity. So for example, argon or any non-metals yang kita ada lah. Okay, what about giant covalent? So giant covalent secara generalnya, it has a hard material and high melting point, but then a poor conductor of heat and electricity. So kalau yang ni, this one applies to diamond. I mean like generally it applies to any giant covalent structure lah. Tapi kalau specifically pasal graphite, yang beza dia kat sini adalah kalau graphite it's not that hard, dia soft je sebenarnya, but then despite dia soft, it has a very high melting point lah. Okay, so dia ada these particular properties. Dia ada high melting point. Kat sini tulis poor conductor, tapi graphite dia boleh nak alihkan electricity tu, dia boleh buat. Okay, so for example, kita ada carbon yang dalam diamond ataupun quartz. Okay, so that's it class untuk type of crystalline solid. So it is important for you to know what is the difference between the crystalline solid dengan amorphous solid, and then kamu kena tahu juga a few type of crystalline solid juga, which is this 4 solid here. Okay, that's it. Right, bye bye. Assalamualaikum.